This is day 2 on graphing proportional relationships. And so we kind of looked at these concepts yesterday, and what we ended up noticing about proportional relationships is that something needs to be in proportion. Proportion means that we have two fractions set equal to each other. So for instance, if I set y over x equal to another fraction, maybe just m over 1, these would be in proportion. And so that's what we're looking for, because our equation, our initial equation, what we saw yesterday, was y equals mx. And for it to be proportional, we took to find that constant of proportion, which is m, we divided by x, and we found that y over x equals m. And so that's what we're looking for. So I put m over 1 because anytime you have a number that is not a fraction, you can write it as a fraction over 1. So we're looking for this. We're looking for, is the value that we get for the slope always the same? And so no matter which point we end up picking. And so for instance here, if I go starting at 10, and I go over and then down, you see this value right here, this point, is 1, 10, and which means the hours worked per dollar. So for 1 hour of work, we earn $10. And so if I look at the next one over here at 2 hours worked, I earn $20. Or 2, I earn $20. And so you can see how if I go ahead and write those as fractions, if I did y over x, 10 over 1 is the same as 20 over 2. 20 over 2 because 2 hours work for $20 would end up giving me the same exact fraction. Give me 10 over 1. Those are equivalent. And so you can see it because I could cross multiply. 10 times 2 makes 20. Over the other side, 1 times 20 makes 20. So yes, these are proportional. Yes, this is a proportional relationship. And what we're looking for, again, is when the line goes through the origin, it's going to end up being proportional. We'll see that, and we'll write that down later. Now, if we look at this one, if you just take a point, like, for instance, time in seconds compared to height, this point right here, if I wrote that as an ordered pair, it would be 1, 30. And so if I look at its relationship of y over x, it would be 30 over 1. Now, if I compare that to another point that I see where it crosses, and it crosses over here, I'll do this point. This is 6 seconds. It's 5 feet. So that would be 6, 5. And if I look at these two fractions, 5 over 6 for y over x, these are not equivalent to each other. So this is not proportional. And so we'll see that's not proportional again, because when we have that proportional relationship, it should be going right through the origin in order for these variables to, or these y to x values to be constant. So if we take a look at this one, like for instance, here's a point where it crosses. Number of tickets cost is $40. So for 2 tickets, it costs $40. That's what the graph tells us. 2 tickets right here, and going up, it hits the line, going straight across, $40 is what the y-axis tells that is. And so that would be 40 over 2. If I look for another point where it crosses, it looks like it crosses right here. So this is 6 tickets cost $100. So for 6 tickets, it costs $100. So if I wrote that as a proportion, or as a ratio at least, I would have 100 over 6. Now, are these proportional? That means the two fractions need to equal if they are proportional. So if proportional, they will equal. If proportional, then they will end up equaling. And when we go ahead and cross multiply to find out, 6 times 40, so 40 times by 6 should equal 2 times by 100 if they are proportional. But when I go ahead and multiply those, I get 240 equals 200. So I see those are not proportional. And looking at the next one, I've got a line that goes right through the origin here, and it looks like it's one pizza is maybe $5, or maybe that's a little over $5. And then I have 2, it's hard to tell, it's definitely a little over. And I can go with this one here. 5 is at 30. Definitely see that one. And it's hard to tell the other ones. This one might be like a little over, maybe $6 here. So $6 we'll say, but definitely goes through the origin. So we'll say it's 1, 6, and this one is 5 pizzas for 30. So 5, 30. And so when we go ahead and come up with this value, our values are 30 over 5 for this first one here, and this one is going to be 6 over 1. So I see that when I go ahead and cross multiply, 6 times 5 equals 30 times 1. And so these are proportional. So this is proportional. And again, the reason is for graphs is when they go through the origin, the relationships are going to be proportional is what we end up seeing. Let's take a look at another type of problem. So let's say there is no graph. We just have a relation like this where it gives us x values and y values. And so if you wanted to, you could make up an ordered pair, but we don't need to graph these values. See, these are the ordered pairs that we can represent here. But when we're talking about proportions, we're talking about looking at the x values and the y values and writing those as a fraction. And so I'm going to take the easy ones. I'm going to take this one and this one right here. And I'm going to write those as a ratio. So I'm looking at y to x. Again, my ratio is y over x. So my 2 is the y value over x being the 1. And I'm comparing that to this one over here, 4 over 2. And you notice that if I cross multiply here, 2 times 2 makes 4. 1 times 4 makes 4. These are proportional. So yes, this is a proportional relationship. And again, what makes something proportional is that the graph will end up going right through the center, or right through the origin, and up at a 45-degree angle is what we'll end up seeing. And that'll end up, or just any angle. It doesn't even have to be a 45. Just going through the origin will make it proportional. And so that's what a proportional relationship is. So what we're going to do next is do a little review. Find the value of x. And so if I want to find the value of x here, I am going to end up finding out what are the degrees of this polygon. So the way I do that is I count how many sides there are. There's 1, 2, 3, 4, 5, 6, 7 sides. So I use this formula, n minus 2 times by 180, where n is the number of sides. And when we go ahead and substitute in, I've got 7 minus 2, and I'm going to multiply that by 180. And so when I do 7 minus 2, that gives me 5. 5 times 180. And when I go ahead and do that multiplication, it looks like it's going to be 40 and 900 degrees. So 900 degrees is the total of all of those sides. And so what I'm going to do is I'm going to add up all of these sides that I have right now. 140, 145, 115, 120, 130, 128. I'm going to add up all of those numbers. Let's do that. And so when I pull up a little calculator, I've got 140 plus 145 plus 115 plus 120 plus 130 plus 128. So I add those all up and I get 778. And so what I'm going to do from there is, since the total is 900, I need to find that missing angle. So 778 plus x equals 900. So I need to subtract that number from 900. And it's going to give me a negative, but that's because I did the subtraction backwards. And so 122 degrees is what I end up getting when I do that subtraction. That would be what the value of x is. So moving on to the other types that are review, here we have a proportional relationship we're going to see in this case. And so let's go ahead and take a look at what it is. So I know it's proportional because y equals 3x. So it does not pass through any other point on the y-axis, just the origin. And so what we talked about is that this 3, the number that's changing x, is that constant of proportionality, which is our slope. It's our rate of change. And that rate of change is a fraction, 3 to 1. And so I see it crosses at the y-intercept at 0. And so that's my y-intercept. So I'm going to start there at 0 and then just use that constant of proportionality in this case, because this is a proportional relationship. It goes right through the origin at 0, or right through the y-axis at the origin. And so that's what our graph would end up looking like. On this one, we don't have a proportional relationship because the y-intercept is not 0. So this ends up being our y-intercept in this case. It's positive 2. So we walked up 2 spaces on the y-axis, put a dot there, and then used that constant rate of change, which we call our slope. And so the slope is a negative 1 to 2. So I'm going to treat that as negative 1 tells me to go down 1 space, and then I'm going to go right 2 spaces. So down 1, right 2 puts me on that line. Now, if I run out of room that way, I could change it around. I could go 1 over negative 2, which would tell me to go up, but then to the left. And that would get me on that same exact line. So up 1, left 2 gets me on that line as well. And I could draw a line between those points, and then I'd have a nice line. So on this one, we have just x. There's no y here. So this is actually a function of y. And that function of y is saying that x equals negative 4. And so x is always going to be negative 4. So if I go over to negative 4 on the y-axis, no matter what value of y I plug into the function, x is always negative 4. So this has no slope. It is a vertical line. So whenever we see that x only, that's when we have that vertical line. And again, there is no slope or undefined slope is what we end up seeing on that vertical line. On this one, we do have a function of x, just as we did with the 2 on the top here. This is a function of x that always is negative 1.5, because the function of x is what the y value is. Y is always negative 1.5. So that means you're going to go down 1.5 on the y-axis, and it's going to be a line no matter what the x value is. Y is always going to be negative 1.5. So this one ends up being that horizontal line. So again, when we see no x value, no x, there's only y, this is going to be a horizontal line is what we'll end up seeing in this case here. So this one has 0 slope. Now don't get confused with no slope. No slope means it doesn't have a slope. It has undefined slope. It's straight up and down. We cannot go over any spaces, which means we have a denominator of 0. Here we have a numerator of 0. You can divide a number into 0, just can't divide 0 into a number. So 0 slope on the horizontal, no slope on the vertical. Those are the types of problems you're going to see on tonight's homework. Good luck.